You are sprinting through the dense, prehistoric brush in pitch darkness. You can hear heavy branches crashing behind you. An indistinct shadow is gaining ground. Your lungs are burning. You look back, and the creature lunges. You trip. You fall. And instantly, your eyes snap open. You are sweating, breathing heavily, and your heart is hammering against your ribs. But there is no monster. There is only a quiet cave and the fading embers of a campfire. You are perfectly safe. Why did your brain just force you to survive a disaster that never actually happened? Producing a full-blown physiological panic attack requires a massive amount of caloric energy and stress. For an early human who desperately needed restorative sleep to survive the next day, enduring absolute terror in the middle of the night seems like a severe biological disadvantage. Nature rarely tolerates that kind of waste without a reason. To find that reason, we have to examine what happens to your physical body when you enter REM sleep. During this phase, the brain triggers a mechanism called muscle atonia. It temporarily paralyzes your major voluntary muscle groups, locking your physical body in place while your mind remains highly active. But look at this dual-axis chart mapping physiological activity during a nightmare. The bottom line shows muscle activity flatlining due to that paralysis. At the exact same time, the lines tracking heart rate and brainwave frequency rocket upward. Your physical body is completely immobilized, yet internally, your biological systems are fighting for their life. While locked in this paralyzed state, your brain is busy constructing an incredibly vivid, immersive virtual environment. It floods your system with stress hormones like cortisol, making the imaginary cliff you are falling off, or the predator chasing you, feel entirely real. Evolutionary biology operates on strict efficiency. Traits that waste energy or threaten survival usually disappear over millions of years. Because this intense, exhausting nightly phenomenon stuck around, we are left with two options. Either nightmares are a catastrophic system glitch, or they serve a hidden, highly valuable purpose. One explanation for this nightly physiological tax is the threat simulation theory, or TST. Proposed by cognitive neuroscientist Auntie Ravenswoe, this hypothesis suggests a specific evolutionary reason for why we experience terrifying dreams. The core proposal of threat simulation theory is that the ancestral brain did not use sleep purely for rest. Instead, it used part of the night to boot up a biological virtual reality simulator, an internal training ground designed to rehearse critical survival skills. Early humans lived in an environment defined by unforgiving metrics. Navigating treacherous cliffs, avoiding lethal predators, and escaping rival groups were daily realities. In that world, a split-second delay in threat detection was the singular difference between living to see the morning and being removed from the gene pool entirely. We can map out how this internal simulator functions using the cyclical flowchart. It starts at the central node. A simulated threat appears. This forces the sleeping brain into detection, triggers a rapid reaction, and launches an attempted escape, before looping back to memory rehearsal. The brain creates a safe sandbox to test evasion tactics. You practice running from a wolf, but if you fail, you suffer no broken bones and no actual death. If this hypothesis is correct, a terrifying nightmare is actually a biological favor.
It is a prehistoric danger drill that gave our ancestors a crucial edge in a dangerous world. It sounds like a perfect evolutionary explanation, but it raises an immediate logistical problem. How do scientists actually test a theory about something happening entirely inside the subjective darkness of another person's mind? Researchers rely on a rigorous system of dream journals and threat content scoring. By collecting thousands of dream reports from diverse populations globally, scientists can quantify the exact types of threats people encounter while they sleep. This horizontal bar chart ranks global dream themes. Survival scenarios dominate, being chased, falling, and attacks. Furthermore, these simulated threats trigger defensive responses. The sleeping brain reacts precisely like a real-world ambush, firing identical fight-or-flight physiological signals. But here we hit a massive scientific roadblock. If nightmares are a perfectly tuned, highly efficient survival simulator, why does the brain also force us to dream about our teeth crumbling out of our skulls, impossible architecture, or showing up to a hunt wearing absolutely nothing? The threat rehearsal data is compelling, but the sheer, undeniable weirdness of dream logic creates complications. It strongly suggests that threat simulation theory cannot be the only software running in the sleeping brain. The modern world has replaced the physical threats of the Pleistocene era with entirely new anxieties. Our ancient brain hardware evolved slowly, and it hasn't completely updated its threat detection systems to distinguish between the immediate danger of a saber-toothed tiger and the abstract dread of a missed email. Inside the simulator, the prehistoric predator simply changes shape. It seamlessly morphs into an impending exam, a looming deadline, or the fear of social rejection. The primal feeling of being hunted remains exactly the same. Sometimes this simulation mechanism gets stuck on a punishing loop. Frequent, highly distressing dreams can develop into nightmare disorder. Fortunately, sleep medicine offers proven tools to handle this, like imagery rehearsal therapy, which allows patients to consciously rewrite those recurring bad scripts while awake, training the brain to find new outcomes. Because dreams are complex, scientists maintain a wide list of alternative suspects for why they happen. Many researchers argue that dreams are primarily for memory processing, emotion regulation, essentially filing away the day's events and untangling complex feelings, rather than running physical survival drills. The scientific community remains divided. Your nightmares might be ancient survival simulations keeping your instincts sharp. They might be bizarre cognitive byproducts of memory consolidation. Or they might be a messy, intertwined combination of both. The next time you wake in a cold sweat, heart racing in the dark of your bedroom, you are experiencing an ancestral legacy. This is a mechanism that has operated within the human lineage for millions of years. Whether it is a highly evolved danger simulator meticulously preparing you for the worst, or just the strange, vivid exhaust of a brain filing away its memories, your sleeping mind is a relentless and fascinating world builder. Science has not yet mapped every corner of that world. The mystery remains open. And tonight, when you close your eyes, you get to wonder whether your mind is simply drifting to sleep, or if it is secretly running prehistoric danger drills in the dark.